How is it going? I hope you are having a great time at the conference. I'm really sorry I could not join in person, and I can't tell you how much I wanted to be there. And I'm really missing the conference and having this FOMO right now. But never mind. As a way to celebrate and get over this FOMO, I am going to order a delicious dessert right after my talk. Yeah, yes. So, since I'm giving this talk virtually, and I might ask some questions just to interact. It's simple questions which answer could be yes, no, or anything. So I would like to request all the online audience if you could interact via Discord, and to audience who are actually present at the venue, if you could join Discord, that would be great. But if you can't, you can just say it verbally. Maybe I'll be able to hear it, or maybe you could just, if you want to say a yes, maybe you could just clap. So yeah, let's do that. Just before this talk, before my talk, Tejas was using Excalidraw, and I got really excited to see this. And how many of you have actually been using Excalidraw? Or how many of you actually know about Excalidraw? Okay, maybe I'm able to see some hands, but I'm for sure that there are a lot more hands outside this camera, so I'll assume it's a big number. So, and if you haven't checked out Excalidraw, just go to excalidraw.com and check it out. I'm sure you will love it. So I'm Aakansha Doshi. I'm one of the core maintainers of Excalidraw. And as I started contributing to this tool, I got addicted to it so much that I decided to work on it full time. So yeah, that's how my journey started with Excalidraw. So in the meantime, I actually set up my screen sharing. How many of you have actually used Excalidraw for collaboration or maybe to share your mockups with your friends or teammates? Okay, so let me just set up. Yeah, I think my screen share is set up now. And yeah, I can see it. I had to clean my desktop so that, it's clean enough. So yeah. So when you are actually using Excalidraw to share your mockup with your friends or with your teammates, how can Excalidraw help you as an application to make sure that your data is secured to handle the privacy? So for that, we have end-to-end encryption. Now, what do I mean by end-to-end encryption? So whenever there's a data exchange between a sender and a receiver, the network that data, when you are actually sharing it between a sender and a receiver, so yeah, sorry about that. So yeah, so whenever there is a data exchange between a sender and a receiver, that no one in between, nothing in between, not even the server will have access to the data, which means that the data gets encrypted on the sender's end and gets decrypted on the receiver's end. And this actually gives you the maximum level of privacy, right? So I'll be actually diving in how end-to-end encryption works in Excalidraw and how we have implemented it. But before that, let's actually have a walkthrough how encryption in general works in a client-server architecture. So in a client-server architecture, whenever there is a data exchange between a client and a server, that network, that communication is actually encrypted with the help of HTTPS. This is great. That's awesome. But hey, we are still storing the content, raw content on the server. And what if the content gets compromised on what if the server gets compromised at any point of time? Your content could get compromised too, right? And that would be a nightmare. That would be like, we really want to avoid this. Really, we wanted to avoid this. So we came up with another model that, hey, instead of sending the raw content over the network, let's first encrypt the content on the client, send it over the network, and then store that same encrypted content on the server as well. This way, we did overcome the first problem that, that any point of time, if the server gets compromised, your content is still safe because it's encrypted. But to make sure that the server doesn't have access to the encrypted content, how you have to make sure that server doesn't have access to the encryption key as well, with which the data is encrypted. So how do you do that? With means that we need to hide the encryption key from the server as well. So that was one of the interesting challenges to solve, and the way it was solved is actually really interesting. So in a URL, whenever you have this hash, whatever parameters are present after this hash, they are never ever sent to the server. And that's the default browser behavior you get. So in this case, key equal to XYZ is never ever sent to the server. So we said that, hey, why not take advantage of this behavior to store the encryption key right after the hash? That way, we are going to achieve our goal of not sharing the encryption key with the server. And also, we don't really have to do anything extra implementation on top to achieve this because we are getting this out of the box. So the first thing was solved that, hey, we are going to hide the encryption key from the server. Now, what is the next thing? So next thing is we need to actually encrypt the data on the client because now it's solely the responsibility of the client to actually handle the encryption. So how do we do that? For that, we have web crypto APIs and their great support in the majority of the browsers. So yes, we decided to use this web crypto APIs to actually build the end-to-end encryption model. So before I actually dive into how this web crypto APIs work and how do we use it, there are a couple of things we need to understand. So let's just have a quick overview of these web crypto APIs. So the API which we are going to use is window.crypto.settle. The settle, as the name suggests, these are really low-level APIs. So, and there are a lot of algorithms for each. There are some strict requirements which you need to follow when you are using these algorithms. So, and if you don't follow those rules and regulations, you might not get the security. You will not get the security which is expected. So that's why it was named window.crypto.settle. And it's only available in HTTPS for security reasons, of course. So if you use HTTP, crypto.settle will be null or undefined, but it will not be available. So yeah, and anyways, you should try to avoid HTTP. The APIs in this are really generic, which means if you try to look at the APIs for encryption and decryption, you will see that these APIs are not really specific to some algorithm. Rather, they take algorithm as one of their parameters. And if this API, crypto.settle, supports that algorithm, it will work. Otherwise, it will not work. So all the APIs are really generic in that way. It deals with only binary data, which means that the input and output of this APIs will always be binary data. And we are going to talk a lot about binary data in the upcoming slides as well. And most of these APIs actually return promises. So we are going to use async await a lot as well. So yeah, that was like a quick overview of window.crypto.settle. Now, before we actually dive into the crypto APIs and how to use them, there are a few things we need to understand. So actually, let's look into that. So how do you actually handle this binary data in the browser? We need to deal with binary data because that's how these APIs work. So for that, we have something called typed arrays in JavaScript. The typed arrays, there is nothing like reserved keyword as typed arrays. It's basically a category of arrays. And as the name suggests, it's typed. So you can't really store anything and everything is in these arrays. You can only store numbers. And it helps you to manipulate the binary data right from the browser. So we have a list of typed arrays actually which are supported. So here is that list. And we are actually going to cover only U in data array in this talk. U in data array, U is basically stands for unsigned, which means it's going to store only positive values. Int is for integer, and 8 is the index of the size of each index, and this array is going to be 8 bits. So yeah, that's what U in data array stands for. Now let's have a look how this U in array works internally. So let's look at this stream of bytes. Let's consider the stream of bytes. Now, since each index can be maximum 8 bits long, so the values which you can store into it is going to be between 0 to 255. And what happens is this stream of bytes gets divided into 8-bit segments. And now each 8-bit segment gets converted to its equivalent decimal. So, and now when you see this array in the browser, this uint array in the browser, this is exactly what you see. And of course, behind the scenes, it's that stream of bytes which you saw. But yeah, when you're viewing it in the browser, this is exactly what you see. So yeah, that was a little bit about how uint array works. Now, in order to use it, let's look at a couple of examples. So you can actually initialize it with some arbitrary length and it will be filled with all zeros. You can even initialize it with some arbitrary values and it will fill it with those values. You can even represent text in form of bytes by using this text encoder.encode API, which basically converts each character in that string to its equivalent decimal or ASCII value. And you can even represent emojis. So yeah, I mean, UA data array, as you can see, it's like you can represent pretty much any form of text with it. And that's why it's like one of the standard and most recommended typed arrays when it comes to the usage. So this was a little bit about the UA data array. Now, before we dive into the crypto APIs, there are a couple of things we need to understand. So let's actually get into that. So crypto key is the first and the most important thing. So what is a crypto key? Well, a crypto key is basically an opaque representation of a cryptographical key with which you encrypt or decrypt your data. Now, when I say it's an opaque representation, it means that you can't really view the bytes of that key directly. Even if you are the developer who has generated it, still you cannot view the bytes. What you have access to is just these 4 parameters which you are seeing on the screen. So let's see what are those parameters to which we have access to. So you have access to the type of the crypto key, which means what type of crypto key is it? Is it a public key? Is it a private key? Is it a secret key? What type of key, depending on the algorithm you are using. For what purpose, what algorithm have you generated this crypto key? So this algorithm will be basically the name of the algorithm and any additional parameters which it requires. And for what purpose are you going to use this crypto key, whether it's encryption, decryption, signing, what is the purpose? So let's say if you specify that you are going to use this crypto key only for encryption and you try to use it for decryption, then it will not work. So you need to be sure about the usage from like at the time of generation itself. And extract table, this is the most interesting parameter and one of my favorites too. So as I told you that you can't really view the bytes of the crypto key directly, but if you want to view the bytes later, let's say when I'm sharing a mockup with you in Excalidraw, I need to share with you the encryption key so that you can decrypt the drawing at your end and you can view the mockup. So for that, I need to view the bytes. And for that, I can actually set this parameter as true. So if you set the extractable parameter as true, you can extract the bytes of the crypto key using the API export key, which I'll be covering in a bit. But if you set this parameter to false, then you can't view the bytes. So you need to be sure at the time of generation that whether you need to extract the bytes later or not. So that was a bit about the crypto key. Now let's decide on what algorithm we are going to use for encrypting. So we are going to use AES GCM algorithm, and it's a symmetric key algorithm. So by symmetric key algorithm, I mean that when I share the mockup with you, me and you are going to use the same key for encryption and decryption. And that's where it's a symmetric algorithm. And when it comes to symmetric algorithm, AES is actually one of the most standard recommended algorithms. And GCM is one of the modes which actually, and it's also one of the recommended modes. The reason being it comes with authentication, which actually protects the data from being tampered or corrupted. And 128-bit is basically the encryption key, the length of that encryption key, which we are going to use to encrypt the data. So now, since we decided what algorithm we are going to use, let's have a look. What are the parameters or the additional things this algorithm needs in order to encrypt the data? So let's have a look at that. So of course, we need a crypto key. We just talked about it, and every algorithm will need a crypto key. So we will be using a 128-bit crypto key. And in addition to that, it also needs an initialization vector or an IV. So what is an IV? Well, IV is just a set of numbers, but a unique set of numbers. And what it does is it adds some randomization to your algorithm, making it more stronger and harder to decrypt. So by this, what I mean is that when you try to encrypt same bytes of text multiple times, with the help of this IV, it will generate a different ciphertext every time, hence making your algorithm more stronger and harder to decrypt. So, well, I think we covered a lot of things, a lot of new things, and visualization always helps in a better understanding. So let's actually, I have a quick demo to show you to visualize things in a better way. So let's actually go to that demo. So I prepared this quick demo for this talk where we have all the parameters here, the crypto key, the encrypted buffer, the IV, whatever we have been talking about. So let's just play around with it. I'll try to generate a crypto key, and this is the crypto key which you can see. And let me just try to view the bytes. Okay, I'm not able to view it. Okay, the key is not extractable, and this is expected, right? This is what I was talking about, that if you set the extractable parameter as false, which is set as false here, you cannot actually view the bytes. So let me actually set it as true and try to generate it again. So this time you can see the extractable parameter is set to true, so it should work. So let me try to view. Okay, I was able to view the crypto key. Great. So now this is the exported crypto key which I can just share with you, right? And I'll be actually referring exported crypto key as encryption key just to differentiate between the two, so it's more clear. Now let me just write some message. So since it's React Brussels, maybe I'll just write React Brussels, and this is the bytes version of React Brussels. And let me try to encrypt it. So we have the encrypted buffer, and we can see the IV as well. Now let me try to encrypt it again and again. Now if you see, the encryption key remains the same, but the encrypted buffer is changing, and so is the IV. This is what I was referring to. That IV helps, IV adds its randomization to your algorithm, and it will make sure that when you encrypt the same bytes multiple times, it will generate a different ciphertext. So yeah, this is all good. Now let me try to decrypt it. So let me just copy this buffer and try to decrypt it here. And I need the encryption key as well. So let me just copy that. Yeah, I need the IV as well. Okay, so let me just copy this IV as well here. And yeah, now, okay, it didn't work. Why it didn't work? I did copy everything, but I don't know if you noticed, I actually changed the IV here. So let me change it back. And this should work. Woo, this worked actually. So yeah, now the decryption actually successfully happened. But one thing to notice here is that I had to enter the exact same IV and the exact same encryption key with which the data was encrypted. So that is something to keep in mind, that when I share the mockup with you, I need to actually share with you the same encryption key and the exact same IV as well, so that you can decrypt the data successfully at your end. And you can play around with this mockup. It's also available in GitHub as well. So yeah, now actually let's go back to the slides. So before actually going back to the slides, let me just show you just a mockup which I'm going to share. So let's consider this is the roadmap which I want to share with you. It's made by Fermin, so thank you, Fermin, for making it. So this is the mockup I want to share with you. So what I'll do is I'll just try to export it and with the URL, I'll just create a link. And this is the link which I'm going to share with you. So now when you open this link, how the decryption happens is what we are going to talk about, and how the encryption happens on my side when I actually export it to this link. That's what we are going to discuss next. And the reason I have wanted to open this mockup is just to get an idea that how the data looks like. So it's basically, you can see there are a lot of elements. So each element we need to represent in some form. And each element in here, let's say it's actually represented in form of this JSON. So you can see the type, the XY coordinates, width, height, and a lot of other attributes. And there is a collection of elements, like hundreds of elements. So it's basically array of elements in that case. And that is the data I want to encrypt at my end. So now let's look at the encrypt algorithm, the encrypt API. So the encrypt API looks like this. What do I need? I need the IV, I need the crypto key, and I need the data, but in bytes, because that's how it deals with the binary data. So we'll look at it one by one. So let's look at the IV first. How do you actually generate the IV? We of course need it, as we saw in the demo, but how do we generate it? So it's pretty straightforward. Since we are going to use a 12-byte IV, so I'll just have it filled with all zeros, initialize the unit data array with 12 bytes. And now I need to fill it with some numbers, right? So for that, we use crypto.getRandomValues. And what it does is it basically fills the array with randomized values. And when you are using crypto APIs, it's recommended that you use this getRandomValue API, because it helps you to generate more stronger and harder to brute force values as compared to math.random. So yeah, if you are using crypto APIs, then definitely you should go for crypto.getRandomValues. So we have the IV generated. Now, what is the thing we need next? Crypto key. So crypto key, we already know what is a crypto key, but how do we generate it? So yeah, we already have an API for it as well. So let's look at that. So crypto.settle.generate key is the API we are going to use. Length of the crypto key is 128 bits as discussed. And the key will be extractable, of course, because I need to share the bytes with you. So I will mark it as extractable. And we are going to use the same key for encryption and decryption. So yeah, we have all the parameters set. Once this promise is resolved, we will have the key. So we have the crypto key as well. Now, what is the thing we need next? We have the IV. And this is the crypto key, exactly the same thing which I showed you in the demo. This is what it will look like. and we have the parameters all set. So we have the crypto key. What is the next thing we need? We need the data in bytes. And the data is right now the array of elements, right? And we need to convert it into bytes so that it's compatible with this API. So how do we do that? And actually, that is very simple. What you do is you can actually just stringify that data. And now that it's stringified, how do you convert that string into bytes? That is what we are going to do. And for that, we already saw that we have text encoder.encode API. Just pass in that string and it will give you the bytes. So yeah, we have actually encoded it and we have all the parameters in place. So let's just go ahead and encrypt the data. So yeah, once this promise is resolved, I will have the encrypted buffer with me, which I can actually upload to the server. But before that, let's take a little pause here and make sure that everything is set correct. So I will be uploading this data to the server, and you can download it, or you will get the data. I will be sharing the encryption key with you via the URL as discussed. Is there anything else which we need to make sure that you decrypt the data successfully at your end? Is there anything which I've missed? The IV is also something you need, and that to the exact same IV with which I'm encrypting the data, right? So that is something I need to share with you. So how do I share with you? How do I share it with you? Well, IV is not really something which is secret. It's basically a unique set of numbers, and we are going to change it with every encryption. So what I can do is I can just make it part of my payload, which I'm going to upload to the server. So what I can do is the first 12 bytes of my payload will always be IV. And this is the information I'll be communicating with you that, hey, the first 12 bytes are always going to be the IV. So if you need the original IV, just extract it from the payload. So yeah, now I have the payload ready. So I'll just upload it to the server. And once that is done, my backend part is done. The data is successfully uploaded to the server. Now what is left? I still need to generate that link which I was talking about. And for that, I still need to extract the bytes of the crypto key so that I can view the bytes and share it with you. And that we haven't done yet. So let's try to do that. And for that, I mentioned earlier that I'll be using an export key API for that. And what export key API does is it basically you have to tell to which format you want to export the crypto key. There are a couple of formats which are supported. We will be covering JSON web key format or JWK format. So what it does is it actually, when this promise is resolved, when the export key promise is resolved, it will give you a JSON which has various parameters, and we will just extract the K parameter from it. So what is this K parameter? So JWK response exactly looks like this. And this K is actually the encryption key. And that is what I need. That is what I care about. So that is what I'm going to actually extract and share it with you in the URL. But this is something to keep in mind because this we will be needing sometime later. So let's keep this JSON web key in mind as well. So yeah, now, now I have the K parameter. So let's just create the URL because that is the only thing left from my end. So I'll just create the URL and I'll be sharing the encryption key, and I'll also be sharing the drawing ID with you, which will help you to download the drawing from the server. So yeah, I'll append it to the hash and share with you. So this is the URL which it will look like, and this is what I'm going to share with you. So I have done my job. I have done my part. Now, when you open this URL in the browser, does the decryption take place at your end? Well, you can imagine that it is going to be reverse of all the process which happened at my end for encryption. But how does it happen? So let's have a look at how does the decryption take place at your end. So the first thing which you know is looking at the URL that, hey, you have the ID and you have the encryption key as well. So since you have the ID, just get the data from the server. That is the first thing you do, that just get the data from the server. And now, since you have the data from the server, you want to decrypt this data, right? That is the next step you want to do. So let's look at the decrypt API. Now, if you see, if this API looks exactly same as the encrypt API, so you need the IV, you need the crypto key, and you need the encrypted buffer, which you want to decrypt. So looking at this, does it remind anything in the payload? Like, do you have anything apart in these parameters in the payload already present? So you have this original IV and you have this original blob already as a part of your payload, right? I did share it with you. The first 12 bytes will always be the IV and the rest is the encrypted blob. So now what you can do is you can just extract the first 12 bytes of the IV as the IV and the rest is of course the encrypted blob. So you have the original IV and you have the original blob. Now what is left? Crypto key is left. What I shared with you was the exported crypto key or the encryption key, right? And now you need to convert it back to the crypto key in order to be compatible with this API. So how do you do that? Well, now we actually are going to do a reverse of all the processes which I did at my end to extract the bytes. The way I did it was I actually I took the crypto key, exported it using the JSON WebP format, and then extracted the K parameter out of it. Now, what you are going to do is you first need to go back to the JSON WebP format. And for that, you only have the K parameter, right? So just what you can do is just add the additional missing attributes which are missing to actually convert it to the JWK format. So that's what you are going to do. And then you get this particular format, which is the JWK format. So once you have converted to JWK format, we need to convert this to a crypto key. So for that, we actually have an API for it, which is basically the reverse of export key API. What it does is it will take this JWK format, the exported key, and it will give you back the crypto key. So for that, we are going to use crypto.settle.import key API. And when you use this API, you can specify all those parameters which you were specifying when generating the crypto key. So you can say that whether you want it to be extractable and what is the usage of this key, and those parameters you can already display here as well. So since the usage is going to be only decrypt, so we are actually going to, we don't need, there is no more users left after this. So we are going to only specify decrypt here. And we don't really need to view the bytes after this process, after the decryption is done. So extractable is also set to false. So now you have the crypto key generated as well. So just go ahead and, decrypt the data, and then you can just JSON parse and decode the data to actually view the exact mockup. And yes, the end-to-end encryption is actually built. We successfully built it, and we actually did a deep dive into how end-to-end encryption works. So yeah, next time when you are building an app and if you think that the server really doesn't need to access the data, then you might want to think about end-to-end encryption, and you might want to build end-to-end encryption in your application as well. So before I actually wrap it up, I would actually like to give a huge shout out to all the contributors who have helped us the long way to make Excalidraw what it is today. So yeah, huge shout out to all the contributors. And yeah, thank you everyone. I'll catch you definitely next time in person. And thank you, the organizing committee, Amin and Omar, everyone for organizing this conference. And if you have any feedback, please do share. I'll be really looking forward to it. And yeah, thank you everyone for any